Ciao! I'm Antonio, Lab Coordinator at OpenDot, and today I want to introduce you to the lesson in Parametric CAD I will hold during the Design in 3D Technologies for Health&Care Summer Course. During the lesson we will use Fusion 360, a versatile CAD software with a solid foundation on parametric design. And in this introduction I'll make sure that you have its basic concepts covered before the course starts. You can download the Fusion 360 installer from Autodesk website. If it's your first time using it, you can make a year-long free subscription for personal use that will feature all of the software functionalities. Once you've installed and created an Autodesk account, we can start designing. Remember that many features of Fusion 360 are cloud-based, so to use it at its best, you're going to need an internet connection. Let's fire up the software and log in with your credentials. And then you'll be ready to work. Let's start by inspecting all the sections of the software. In the topmost part, you can see the usual functionalities of most modern softwares, such as file management, save, undo, and redo. The first icon is something more interesting. It will open the data panel, the area of Fusion 360 where you can manage all your projects, including those of your team if you're part of one. Since this is connected to your account, you can retrieve your project of any computer with Fusion 360 installed. The bar just above the main window shows many tools divided in several sets. The first button on the left is used to change the workplace. Workplaces are the way Fusion 360 contains different applications inside the same environment, such as CAD, CAM, rendering, and much more. For the scope of this introduction video, we're going to cover only the design workplace. Most of the window is occupied by the work area. It is where you will draw your designs, model your 3D objects, and make your assemblies. In the upper left corner, you can see the browser. It is where Fusion 360 lists all the components of your designs, such as sketches, components, bodies, views, and more. Soon you'll see how it will be populated. In the upper right corner, there's the View cube. This tool is used to change the camera position. You can click and drag it in order to change dynamically the viewport, or select one of the key points, or adjust the position with the arrows. The home icon will quickly get you back to the default view in case you ever get confused or lost. At the center in the bottom there are more controls regarding the camera position and the work area view settings. Explore these tools to understand the capabilities at your disposal. Last but not least, in the bottom left you can see a set of player controls. These are used to navigate through the feature history. We'll talk more about it in the later steps. Once you get confident with the environment, it's time to start to design. The most common way to design from scratch is by drawing first a two-dimensional sketch and then derive a 3D model from it. Let's see how this is accomplished in Fusion 360. First of all, click on the Create Sketch button. Then you have to choose which plane on the 3D space you want to put your sketch on. Select it by clicking it. As you can see, the toolbar has changed and now you can find different sets of commands. The Create set contains all the tools used to make shapes. The Modify set comprises tools to adapt the shape in your sketch. The Constraints are a useful set of geometrical rules that we can apply to our drawings. Let's check them in more detail. Among the Create set, you can find tools to make both simple open or closed shapes, such as lines, rectangles, arc and circles, or more complex features like spline bands, patterns, or polygons. Let me draw some shapes that we're going to use later. An important sketch feature is the construction property. This can be applied to any line or shape and render them as usable only for geometrical reference, meaning they will not be considered for 3D modeling. You can see they're different from the others since they are dotted and orange, while the normal lines are blue. A good way to make complex but still coherent shapes is to apply geometrical rules to them with the constraints. Each one has a specific purpose and can be useful in many ways. It's worth the effort to experiment with them all in order to understand all the possibilities they enable. For example, in here, I will coordinate these shapes with different constraints in order to make a more complex shape. As you might have seen, many features are added automatically while I'm drawing my sketch, meaning that when I adjust the position of this line over this circle, it will automatically add a coincident constraint, as well as when I put this circle inside this other one, it's going to make it coincident. Or you can see from these rectangles that they all have horizontal and vertical constraints already applied. You can define directly the dimension of a feature while you're drawing it by typing the numerical value. Or you can revisit later with the Sketch Dimension tool in the Create set. See that when I set the diameter of the circle, also the circle constraint to hit changes. Let's make some finishing touches in order to make everything coherent. Once you've done drawing, click on Finish Sketch to get back to the main set of tools. Now it's time to jump into 3D space. Extruding 3D models out of 2D shapes, it's a really common feature in task software, and in Fusion 360 these tasks offer many parameterization settings. Let's check them out. You click on the Extrude tool, and then choose the surface you want to extrude. In my example, I want to make a single side extrusion over this polygon. Choose direction one side and set the distance. See that I can change the extrusion even by using the arrow or setting it numerically. As you sketch and model, you can see the browser list growing. In this section, you can quickly choose a particular feature. And since by default, any modeling operation on a sketch will hide it, in case you need to work more on it, you can show it again from the browser list by clicking on the icon. In my case, I'm enabling the sketch in order to extrude again from a different feature. Now I want to extrude a double side extrusion from this shape. Let's select all the features. Set direction as symmetric and set the distance. Click on OK and you have your new shape. Revolve is another useful tool, allowing to rotate a shape over an axis. It's useful to make both non-trivial cylindrical shapes and spherical shapes. Notice that when I revolved the spheres, they added their shapes over the existing body. I can also extrude in order to add to an existing volume or to remove from it. Let's see how. I hide this body, select Extrude, and then select the feature I want to extrude. I choose Extend up to Object, so in order to delimit the surface, and choose the operation Cut. When the bodies are ready, you can delve into more articulate spatial operation. For example, you can rotate and move a body to have it intersect with another one. You do so with the movie copy command. In my case, I selected the polygonal cylinder and rotate it by 90 degrees using a move type as free move. 90 degrees. And then I move it according to a point-to-point movement. I select the body, I choose the kind of movement, point to point, and then select the points of the direction. This one and this one. I also tick the checkbox Create Copy in order to make a copy of the existing object. Click on OK, and that's it. Now I want to scale the original copy. I use the Scale tool, select the body, and choose a scale factor of 0.7. Then I move it again. I select the body, choose a point-to-point movement, origin point, this point here, and target point as this one. As you can see, now they are overlapping. In CAD design, making Boolean operations with solid models, it's a really common practice to make non-trivial shapes out of simple ones. Boolean operations allow to get volumes by adding, subtracting, or intersecting overlapping models. To make Boolean operations, I use the tool Combine. I select the kind of operation that I want, for example, join, in order to add this one over this one. And then I say OK. Now this is a single body. Then I want to make a different kind of operation. I want to make a subtraction, and I use the cut operation. I select my target body, I select my toolbar, and then I select my tool body. In this way, I got the shape of the hexagonal cylinder dug into the bar, obtaining in the process a rudimental Allen key tool. It's time to look at a simple parametric implementation. In Fusion 360, the Change Parameters button opens a dialog where you can prompt or modify parameters through the plus symbol next to user parameters. When you define a new parameter, you have to provide a name, which identifies uniquely the parameter, a unit, which defines what kind of parameter it is, and an expression, which is either a number or a formula that will define the parameter value. You can also define parameters according to other parameters. Once the parameter is set, you can invoke it by typing its name in a field. For example, when you define a feature in a sketch or setting the value of a modeling operation, such as the depth of an extrusion. I'm going to use my just set parameters along with the feature-based philosophy of Fusion 360. You might remember that at the beginning I talked about the feature history controls. Can you see this section is now populated with icons? This represents every operation I've made in my work area, and with the player controls I can move through them and change any moment of my history. For example, I can roll back up to the sketch definition and change the dimensions of the shapes I've drawn at the beginning. I do so by using the Sketch Dimension tool. When the field is available for change, you can prompt the parameter name and set it. Notice that it is suggested in the drop-down list as I'm typing. Now, if I save the sketch and roll over up to the last step in the feature history, I can see how the changes affected the final result. Furthermore, I can change the parameter expression and update the design again. This is it for this up and running introduction to Fusion 360. There's much more to talk about both for the software and the workflow paradigm. But even with these simple instructions you can figure by yourself the big potential at hand's reach. We'll see more in the upcoming lesson. Thank you for watching and see you soon. Ciao!